The moon is rusting, and chances are it's happening because of Earth. You'd say that since they're more than 230 miles apart, they can hardly directly influence each other in such a way. But they do actually have a special connection. The moon affects our home planet as well, and you can see it while observing ocean tides. As Earth rotates, the moon's gravitational force pulls the water on the nearest side of Earth. It creates a bulge. At the same time, another bulge forms on the opposite side because our planet rotates, and it causes a centrifugal force. And then the planet continues to rotate underneath these bulges, which is why we have 2 low and 2 high tides every day. Plus, the moon wobbles every now and then, tilts more or less, and causes changes in ocean tides. And in return, Earth's atmosphere is making our satellite rusty. Rust is that reddish substance you see on old gates or nails. Oh, and you know Vermilion Cliffs and the Grand Canyon? They also have that specific red color thanks to rusty iron in the rocks. It forms when iron reacts with oxygen and water. Rust is common even on Mars. The planet's trademark color comes from the rust that's been there for a very long time. That's how the red planet got its nickname in the first place. Normally you wouldn't say the moon is a place that would rust that easily since it's dry and doesn't really have an atmosphere. But a spacecraft studied the moon back in 2008 and detected spectra, wavelengths of light that were reflecting off different surfaces of the moon. That's why it could analyze the lunar surface better. And the data it brought showed that the lunar poles had different compositions than the rest of the moon. They had rocks that contained a lot of hematite, that sort of specific type of iron oxide, or simply rust. No one expected that because there shouldn't be so much rust on the moon considering the conditions there. But we know that there's some water up there on the surface of our satellite. That's why a few new theories popped out about different materials the moon could be hiding. It's possible that they formed because water had reacted with the rocks. For iron to get this rusty hue, it needs something we call an oxidizer. That's a molecule that removes electrons from materials like iron, such as oxygen. But the solar wind keeps hitting the moon all the time, and it brings hydrogen with it. And hydrogen has the opposite effect. It gives electrons to other molecules. Earth has its shield from the solar wind. It's our magnetic field. But the moon doesn't have such protection, and because of that, rust shouldn't be able to form on its surface. But this process still happens, and it could be Earth's fault. The moon itself doesn't have an atmosphere that could provide enough oxygen for iron to rust. But apparently our planet is generous enough to donate some of its own atmosphere. The oxygen from our atmosphere travels all the way to the moon, following something called magnetotail. That's a long extension of Earth's magnetic field which can reach the near side of the moon. That's exactly where most of the hematite was found, and during a full moon, the magnetotail blocks 99% of the solar wind, which would normally influence the moon more. It's like there's a temporary curtain over its surface, which gives enough time for rust to form. So there's still one important thing necessary for the appearance of rust. It's not like you can find water that easily if you decide to take a walk across the moon. Most of it is frozen and hidden in areas that always remain in cold shadows. Those spots are far away from where most of the hematite was discovered, so it's hard to tell how the water got there. But there's an interesting idea. All those dust particles that hit the moon might be freeing free molecules of water that are locked in the surface layer of the satellite. This is how water ends up mixed with iron. We don't know exactly what these dust particles consist of. They might be carrying some water too. As they hit the lunar surface, this might create heat, which boosts the oxidation process and more rust forms. So, our planet does certain things that change the moon, but humans do the same. A probe that landed on the lunar surface back in 1959 was the first human-made object that touched the moon. That's also when we started altering the moon in unpredictable ways. It's like an analogy with Earth's Anthropocene, a period when human activity made an impact on the planet. It's not like we can choose a certain starting point when such an activity began, but we now know that things we have done over the history of our existence have really changed the environment of our home planet. We don't have any people living on the moon yet, but we've already left some traces there. After humans first came to the moon, we've had many missions there. We left some landers and flags, moved lunar soil, brought golf balls, scientific equipment, and even some human waste. Plans for the future? Send more missions up there and even potentially create an infrastructure where some of us could live, study the moon's resources, and send them back to Earth. That's why it's important to talk about the lunar Anthropocene, to remind ourselves we have to be responsible and take care of our heritage. Many people are confused about why we sometimes see the moon during the day. Some even believe it's something new that didn't happen before, especially after they started sharing a low-res picture of what looked like a full moon in the middle of the day. Some have pretty unusual ideas that the sun isn't the same color as it was before either. Allegedly, it used to be more yellow. The sun hasn't changed its color. It's still blue-green, but it's possible that we saw it as more yellow when we were younger, because before, pollution wasn't as bad. And when it comes to the moon, we can see it both at night and during the day. It's brighter at night because there's no light coming from the sun, but it's not like it goes anywhere during the day. It's still there, but we just don't see it during the new moon phase. That lasts a couple of days, and during that period, the moon comes pretty close to the sun, and the scattered light coming from the sun makes our satellite less visible to us. Speaking of the moon phases, they're easy to recognize when you know what to pay attention to. First, there's the black moon, which can mean a couple things. One definition says that it occurs when we have 2 new moons in a month. Another one claims that the black moon happens when there's no new moon in a month, and that only happens in February. The blue moon is not called that because of the color. It's the 3rd full moon in a season that has 4 full moons, and a supermoon occurs when a supermoon coincides with the moon's closest approach to Earth in its elliptical orbit. That's why it looks bigger than usual. Sometimes you can look up to the night sky and see an eerily red sphere up there. It's not about signs that tell us that the end of the world is coming or that werewolves are roaming around. But yeah, blood moon is a good inspiration for stories like that. In reality, it's just an astronomical event when our planet casts a reddish shadow on the moon, and that happens when Earth comes between the moon and the sun, which is called a total lunar eclipse. Earth's little companion catches some red light coming from our atmosphere, and that's why you see that specific color. Please like and share so everyone knows. Thank you for watching. If you want to know more, stay with Hidden to continue.